Hello guys, myself Akshay and I am going to create a video series for reverse engineering. It's one of the most advanced topic in hacking. In simple, reverse engineering is the act to modify the code of a particular application or a software to make it work as we want. This is a very complicated topic and is very difficult to understand for a newbie as it requires knowledge of assembly language. In this video series, I have covered some basic aspects of reverse engineering. Before watching this video, I suggest that please go through the basics in reverse engineering at www.burstlimit.in. So friends, let's begin. The very first question arises that what is reverse engineering? Well, reversing is also called reverse engineering is the changing of the code of a program. Now, why to change code of a program? This is done to change the looks of a program, to clean from viruses, to enhance a program with other functions, to make it compatible with other systems. Now, what is the goal of this video series? My goal of this video series of tutorial is to show you some techniques about the reverse engineering, starting on an easy target but making this more difficult step by step. No computer knowledge is required except working in Windows as well as knowledge regarding assembly language. The end will be that you will be able to do some basic reversing. Hopefully you will exploit your new gained knowledge in a positive way. I am not responsible for what you do with your newly acquired wisdom. Therefore, I will only target reverse me very old software or application that are no longer updated. Now in this first video tutorial, I will have to give you some theoretical insights. I believe that practice is better than the dry theories, but then also theory is also important. Throughout most of these tutorials, you will use ollydebug and your brain. The first one can be obtained freely at www.ollydebug.de and the second one is your responsibility. Now about ollydebug. ollydebug, hereafter often called Olly, is a ring 3 debugger. It means that Olly works at Windows application level but still can control other applications. By using Olly we can find bugs in a program, not only find but also correct the program. Now what do you mean by ring? I said that Olly is a ring 3 debugger. Now what do you mean by ring? Actually we have four types of rings: ring 0, ring 1, ring 2, ring 3. Ring 0 stands for kernel, 1 and 2 stands for device drivers, and the last one, ring 3, stands for applications. As the number of the rings increases, then the lower are the privileges, and the order of the ring is low, then it means the privileges are high. Now rings are arranged in a hierarchy from most privileged to least privileged. On most operating systems, ring 0 is the level with the most privileges and interact most directly with the physical hardware such as CPU and memory. Now special gates between rings are provided to allow an outer ring to access an inner ring resource in a predefined manner as opposed to allowing arbitrary use only. Correctly gating access between rings can improve security by preventing programs from one ring or privileges level from misusing resources intended for program in another. For example, if a spyware running as a user program in ring 3 should be prevented from turning on a web camera without informing the user, since hardware access should be a ring 1 function reserved for device drivers. However, most general purpose systems use only two rings, even if the hardware they run on provides more CPU modes than that. For example, Windows 7 and Windows Server 2008 or their predecessors use only two rings, with ring 0 corresponding to the kernel mode and ring 3 to user mode. Now it's the time to set up our ollydebug. Oli doesn't need any installing, just download it and unzip it to a directory of your choice. Remember, you have administrator privileges to run ollydebug. Now after setting at the first startup, Oli will ask you for UDD and plugins directory. Solve this like this. Okay, we will see that in next slide. After changing the path, you need to restart Oli and open reverse me. Here reverse me is our target. Here is the icon in Oli debug. Click on it and then a new appearance window will pop out, and then here you will select directory, then go to browse and give udd path. Then first step is to give plugin path. Remember that give udd path and plugin path same and click OK. Now it's how to set up our ollydebug. Now it's the window which of our ollydebug. Here the first one where its name ollydbg reverse me CPU main thread module reverse me. It is the main window or it is the CPU window. Now here on the left side corner, these are the virtual addresses. The next one from the virtual addresses are opcodes, and the next one are the mnemonic codes. Here after the mnemonic codes, these are the this is the functionality of our ollydebug, that it analyzes the whole code and make some commands which are helpful for human to read out the program. Now here is our register window, that is from EAX to EDI, these are the registers, and from C to O, these are the flags. Here EIP shows that it's the entering point of a module. Now at the bottom right corner, here are our stack. The first row, the first column holds the address in which the value in a stack are pushed or popped out, and the left bottom corner shows hex dump. These are the hex dumps. But here is another window pane. This it shows the information about the next instruction is to be executed. Now look at the definitions of that. What are the virtual addresses? When starting a program, the window loader loads the program at a certain memory location. These are known as virtual addresses. Opcodes, in fact, these are the codes that the computer reads and can understand. What are the mnemonic codes? In fact, this is a translation readable for humans from the opcodes. And comments, after Oli has analyzed the code, he put comments here to is our lives. Now here is the some essential information regarding sizes. Here 1 byte equal to 8 bit, 2 digit equal to 1 byte, 2 bytes equal to 1 word, 2 words equal to 1 D word, and 1 opcode equal to 1 byte. Now what are the registers? Registers are special places in your computer's memory where we can store data. You can see a register as a little box where we can store something, a name, a number, a sentence. You can see a register as a placeholder. Generally the size of those registers is 32-bit or equal to 4 bytes. They can hold data from 0 to 8 times Fs. Now before starting our target study, I will advise you to download two files. That is, first one is ollydebug.ini. Paste it to your ollydebug directory and replace your original file with it. Another one is win32.help file. Install this in any directory and show only the path towards it. Download it from http www.tutsforyou.com request.php !258. Its size is 7 MB. Win32 help works flawless for Windows XP, but for Windows 7, whether it's 32-bit or 64-bit, you have to download an update. For 32-bit, the link is given below. It's the direct link. And for 64-bit, you have to personally download it by passing genuine check by Microsoft by following the below link. That is support.microsoft.com KB917607. After a lot of theory, let's go for practical to study our target. Now here is our target. This is reverse me. If we execute it, then it says evolution period out of date, purchase new license. We have to remove this error and make it to a successfully error. Sorry, not error, a successfully pop-up window. Now it's my only debug window. Go to file and open your program. Select reverse me. It's has already been selected. Now only a blink of eyes our only debug analyze the whole code of our program. I said that you must download win32.help file, then you have to show the path to the help file by going to help and then select API help file, and here is my win32. Click OK, open, and that's only. You have to restart your only debug. Now again go to file, open reverse me, and again in a blink of eyes it analyzes the whole code of our program. Now friend, this button, it is used for tracing. It means by execution of a program step by step or command by command. You can use shortcut for this key, that is F8, or you can click on this button. Now because we don't start execution of a program, that's why our this window pane is empty. It shows nothing. But let's execute our first instruction, that is push 0. As we execute our first instruction, you will see that nothing will happen, but if you look carefully, then notice the function of the stack and see how it pushes the value 000 to stack. Here is the value 000 which was pushed at this address. Friends, push is the opposite of pop. It stores the value of the stack and decreases it by the size of operand that was pushed, so that ESP points the value to be pushed. Here is our ESP. Here it is ESP, and if you notice 0012FF88 is the same address as here in the stack window. It means it's point the value to be pushed in a stack. Now if continue our execution, Now up to here you will see that nothing has to happen, but here is a load icon which loads the icon from our executable file. If you want to see the help, then right click and click on the help on symbolic name. Then it shows the about load icon. The load icon function load the specific icon from the executable file associated. As now here our cursor is load, that is for which was described in our executable file, whether it is default of Windows or it was customized. Now we reached here. Here shows that it's a create file. Let's see the help on this. It shows that create function create open creates, opens or truncate file and returns a handle that can be used to access the object. It can also open and return a handle to a directory. So friend, here is this create file function. Create a file, and first of all friend, here if you see a step before this, here is the file name equal to keyfile.dat, which was the file he was looking for, our program looking for. But friends, we reach here. If we do continue execution of a program, then see this text. Evaluation period is out of date and purchase new license. It means if we continue our execution, we reach here, but we don't want that we reach here. And if you notice carefully, then when we start our program or execute our program, then it shows this error, like we and when we click on OK, then our program terminates. It means why this happening, I will show you that. First of all, when we execute, it reaches here and shows the evaluation period at message box. Now after message box, when we click OK, there is exit process, and that's why our program gets terminated. Now our aim is to bypass this message so that this message will not appear. Now continue our execution. Here it says comparison will occur, comparison of EAX register to -1. And if you see in this window pane, it is also says that EAX is equal to 8 times F's. Here 8 times F shows that it is equal to -1. It means our comparison is true, and you know that why this EAX shows -1, because our key file .dat is not present at this time, because our software is not registered. That's why it shows EAX is equal to 8 times F's. So friends, let's again continue our execution. And if you see, then our ollydebug.initial ini file is comes in handy. It shows an arrow. It shows that from here there is a jump to this point, but it is gray. It means that jump is not taken. If it becomes red somehow, then it means that jump is taken. Now friends, here it shows J and Z. It means jump if not 0. Here this instruction says that jump if not 0, but you see that here when the preceding instruction was executed, then our result is 0. It means because the comparison is true, that's why our result is 0. That's why this jump is not taken place. But let's if it's not jump, then we again reach to our bad boy message, and our aim is to bypass this message. That's why we make our program to suppose that it what it's notify that it notifies that our result is not 0, and that's why we set our z flag to 0 by double clicking on it, and you see that magic happens here. Our gray arrow turns to red. It means that when we execute our instruction now, then you see that the whole message box and the exit process both are bypassed. Now after bypassing the bad message, let's continue our execution. And here we reach to a function that is read file. To see the help, you have to click on help on symbolic name. It shows you the help on the read file. In short, read file tries to read our key file.dat for a certain number of bytes which it puts in a buffer at a certain address if successful. Friend, these are the parameters about of read file. If you see that in assembler you will find the parameter of a function pushed to stack in a reverse order, so that when they popped out they come in a regular order. I will make you see more clearly that here file is the first parameter, but if you see here file is the last parameter, then buffer is the next one, and here buffer is the second last. Number of bytes to read 4670. Number of bytes read, it reads this much bytes and overlapped. It shows that the parameters in an assembler are pushed in a reverse order, so that when they popped out they come in a regular manner. Now friends, we reach here read file. Here what read file does is tries to read our key file.dat for a certain number of bytes which put in a buffer at a certain address if successful. Now read file was going to read 46h equal to 70d. H means hexadecimal and D for decimal. It will try to read 46h or equal to 70d bytes from our key file.dat, and then where the file is reside is 402173. It's the place from where it is reading our file, and then it make them to place in a buffer at 40211A. And if you notice that H file reads 8 times F, it means that our file is empty. If our file is found, then it's here is some value rather than 8 times F. 8 times F shows null. It means our file is not found at that time. Keyfile.dat. Now again continue our execution. Here again you will see that J and Z jump if not 0. If you see that here EAX, and if you see the value of EAX at here, then it will 000. EAX is our accumulator register, or you can see also here in the information window which shows the information about the next instruction to be executed. Now we reach here, it shows that if not 0 then jump, but our compare here our test is equal results to 0, because here also it says that EX is equal to 00, and if you see in a register then it's true. our EAX is equal to 0. That's why this jump is not taken place. But if this jump is not taken place and we continue our execution, then you will see that again here is a jump, JMP, it means jump every time. And if we follow this red arrow, then it makes us to reach here. Here it you will see that key file is not valid. Sorry. Again a bad message. Now our aim is to bypass this message also, so that the bad message will not appear while we execute our program. Again the same thing, make your Z flag to 0, and now it jump this step so that we don't reach here. If we continue our execution, then you will see that magic happens again. Now it's XOR EBX and XOR ESI. What XOR does, it clears our register to 0000. Let's take a look to EBX register. Here is our EBX register. If you looked at till now, it is not 0, but as we execute our this instruction, you will notice that our EBX register is cleared and made to 0000. Again the same thing for ESI. Now here is a comparison occur again, but leave this step for the next tutorial. I will make it to clear in the next, because in this tutorial I only want to make this program patch by guiding the execution of a program. That's why I am leaving this step for the next tutorial and make our execution continue. Here is a jump, but here jump is not taken place by J and Z. Here is jump is taken by JL. It means jump if less than. If less than is comparing from here, that's why I leave this part. Okay, if JL occurs, if you notice that this jump is also make us to reach to a bad message. So our aim is to bypass this bad message again, but now this time you don't need to make Z flag equal to 0, but you have to make S flag equal to 0, and you see that our red arrow again turns to gray. That means this time jump is not taken, and continue our execution. You see that a red message occurs in a opposite direction. It means if we execute this instruction, then next, then next, then next, then next, and when we reach here, we again go back here. It means it's a loop which was occurring time to time. Now if we execute our program, then here is a comparison with AL to 0, and if you notice that AL is equal to 0 0, it means AL is equal to 0. Friend, this double 0 shows that it is 0 or null, but if here is a single 0, it means AL equal to single 0, then it means here AL is equal to 30, not 0. Double 0 shows you null and single 0 shows you equal to 30. Now we come to next instruction, JE, short reverse me at this. Here JE is jump if equal. It means when we compare this our AL to 0, then of course it is equal to 0, because here it also says 0 0 and here is also comparison with 0. That's why our comparison is equal, and when we reach here it shows that it is equal, and JE shows that jump if equal. अगर then it jumps here. Now again continue our execution to next instruction, that is JL, jump if less than. If you see the preceding instruction, compare ESI 8, it shows that if ESI is less than 8, then you have to jump at this instruction. It means here ESI is less than 8, but let make our program to suppose that our ESI is greater than 8. That's why we can bypass this instruction, so that we can bypass our bad message. Here what is ESI? If you, from where you will see your ESI is from registers window. Here ESI you will see that it is 0000. It means that our ESI is less than 8. Here our ESI register doing nothing but as the work of our counter register, the work of ECX. Now we have to make again our S flag to 0 and continue our execution. If you notice that in next instruction also there is a jump, JMP, it means jump always. And if you notice that now we bypass our this message, this bad message, and if we follow the red arrow, then look where we reach. Oh, we reach at our destination. You really did it, congrats. It means we have successfully made our program or guide our program's execution so that it reach to a successful message. Now friend, this all is only the guiding of the execution. Till now we don't finalize our patches, so that when we make our program to execute, it execute at this point. If you continue the execution, you will see that the message appears, you really did it, congrats. And when we click OK, it goes to exit process, and when we run, our program terminated. Now reset your program, and this time we will finalize our patches, because now we know each and every jump, that from which instruction we have made to jump. Now let's continue the execution. It says evaluation period out of date. It means we don't make to reach here. Again reset my program. Now from here we made the first jump. Double click it on memory code and make it to jump here. JMP. Click on assemble, then cancel. Now if when we reach here, it every time jumps to this instruction. Now again make our execution continue. The second jump was taken at this point, so that it can bypass this instruction, which leads us to reach a bad message, that is key file is not valid. Now again continue our execution, and it shows key file is not valid. but before we don't want to reach here, that's why we have to make changes at here also. We have made changes at this point, then we reach to this point, and this instruction lead us to reach here. That's why we have to change our this instruction by double clicking it and fill it with nops assemble. And this all instruction with fill with nop, it means it do nothing here. And if we again comes, then it's a loop. And here also a jump is taken je to this point. Here it this jump will not lead us to a error message, that's why we come here. And when we come here, then it's this instruction will make us to lead to bad message, that's why we have to make this instruction also fill with nops assemble cancel. And now when we reach here, then we bypass this message and go to a successful message. Now we made all the changes, but this time we have to save these changes. Hold your left click of your mouse and select all. Right click on the selected area and go to copy to executable all modifications and select copy all. Now again right click on the new pop-up window and save file. Save file with a new name. Let's suppose reverse me this and save. And if you will try to make your new program execute, then it will says you really did it, congrats. It means we have successfully made our program to patched. This program says that evolution period out of date, and this is our new program. It says you really did it, congrats. Now friends, here the points to be remember in this tutorial are basically what I do is guiding the execution of the reverse me as if everything it verifies is simply okay. The first one, if jump takes place by J and Z, sorry it's not from J and E, that if jump takes place by using J and Z, then to bypass that jump set your Z flag to 0. And if the jump is take place by using JL or JE, then to bypass that jump you have to set your S flag to 0. Third one is create file as a function which is used to create a file, and read file is used to read a file from memory which was earlier created. And the last one is computer deals with hexadecimal values. Now friends, at last if you like our video, then please subscribe our channel, or you can also visit us at www.burstlimit.in, or you can like us our Facebook page at the below link. So friends, bye, hope to meet again, thank you.